Okay, as Dave mentioned, we are going to be doing some hands-on, and this is the morning, and so my section is actually fairly easy. There's not a lot of hard lifting in terms of what people have to do in terms of their exercises, but it is a little bit in terms of constructing some BIDS data sets and using some of the PyNIDM tools that I'll introduce people to. So should be fairly straightforward, and we'll see if everyone's virtual box is working. One quick point, for any of the material that we're going through, we have a GitHub repo, and so I've uploaded my slides there, and I think others have also uploaded some content there, and so you can go to github.com/ReproNim OHBM 2018 training. I am section 1, and you can go in there. There's a PDF of the slides. I will be showing some of the commands that I'm walking through, and so if you want those and you want to have them on your computer, you can download that and sort of have it next to your virtual box as you're doing things. So as I mentioned, we are in this section going over fair data, and so there are going to be a bunch of tools that you're introduced to, and again, I mean, many of you might have been working with BIDS data sets and things like that, so I apologize if this is already familiar to you, but just hang in there, and definitely at some point we'll get to things that are more complicated. So first thing I was going to do is give a sort of brief introduction to FAIR, tails into a little of what Dave was saying. One of the key things in this reproducible push for reproducible research has been this concept of open data, so data that can be freely used and shared and built upon. Right now, the question is, well, how do you actually enable people to be able to get that data and use it and build upon it? It becomes even more important as funding agencies start pushing to have more data become available. So for example, people who are funded through NIMH and other funding agencies have to put their data in the NDA data archive, as an example. So as these requirements start coming out and you are required either to share your data or place your data somewhere, some of these repositories do have certain restrictions. So I don't know, show of hands, has anyone had to, or has anyone been to the NIMH data archive? Okay, well, you guys don't count. So that's so the NIMH data archive is a place where NIH is looking to see, this data be contributed, and they do have certain restrictions in terms of how you have to make your data available. So you have to define, what types of questionnaires you gave to your subjects. Data has to be in a certain format. It has to be structured in a certain way. And so there are a lot of things that if you go through your study and then at the end you're like, oh, I now have to make this data open, you've given yourself a lot more work, right? Because you now have to go back and you now have to sort of reconstruct everything and move things around, and wouldn't it be better if from the get-go, you sort of had in mind, what you had to do to make that data open at the end of the study. As Dave pointed out, I mean, there are many reasons to publish data. Increased transparency for one. When you publish your data, people looking to see what analyses you've done or what is contained in your study, it's much easier for them to do that rather than just rely on the paper. Reuse of data sets, and then the other issue is big data from small data, okay? There are many studies that are looking at, as Dave was saying, sizes, using FreeSurfer and other tools to do basically measurements, in certain populations of subjects. And not every study can, have, thousands of people in it. So, as we start aggregating more and more of these studies, hopefully we can start aggregating that data as well, right? And there is, some difference in terms of data mining in terms of what you might want to accomplish. So again, data mining across large sets of studies is not always meant to do hypothesis testing, right? It's actually sometimes hypothesis generation. What are you looking for? What might you want to do down the road? And so these large data sets actually have power in many different ways. And currently, I mean, when one looks at sort of there's a question of the cost of reproducibility, and there's the other issue of cost. How much money are we putting in research that we don't actually have access to, right? And so there was an estimate done in 2014 and estimated that 85% of the data that is collected in research studies is what's technically called dark data. And if one has, 240 billion in research per year, so you have $200 billion, of investment that, is not available. Now, one might say, well, why, why should I publish my data? Do I get credit for that? There are things that have been changing. So data now is becoming treated more and more like a regular research product. Okay, so, when you publish your paper, you can put your paper on your CV, you have the reference, you have what's called the digital object identifier, that little number that's something dot something slash and then a bunch of strange characters usually. And that is basically the identifier for your paper, right? So any of the systems that track research publications, track citation metrics, they use that identifier to say, this is your paper. And so many people have cited it, and you referenced, so many other papers. Same thing is now happening for data. So over the last couple of years, a number of people in the ReproNim projects and some other groups, have been involved in what started out as the Joint Declaration of Data Citation Principles and has now moved on through a number of organizations, including Force 11, which is an organization that brings together publishers, librarians, academics, has basically developed a set of data citation guidelines for the journals. And this now has been picked up. So Elsevier and a number of the large publishers have picked this up, where they are now using standard mechanisms for citation of data just as you would cite papers. And PubMed is also now on the verge of including this. So the data citation information has been brought into the standard metadata for PubMed information. So again, this whole area of getting credit for your data publications, just as you would, your research publications, is now coming, online. And so basically, you'll be able to then, cite your data, just as you cite your publication. And again, the ecosystem is slightly different. You have, for papers, the main thing I mentioned was the DOI, which you see there top right. You have ORCID. So how many people in this room know what an ORCID is? Okay, so hopefully then everyone has their ORCID. So basically that's an identifier of you. And so initially ORCID was able to track your papers, link them with your personal ID, and then sort of create an information object about you in terms of your research papers. Again, in the last couple of years, ORCID has been expanding to include non-traditional publications, so research software, data sets now. So they're expanding what you can add to your ORCID profile. And one of the big differences with data is that not all data repositories issue DOIs, so these digital object identifiers. So the data space is a little more diverse, and so a lot of databases use also accession numbers. So if you've ever seen, PubMed is a good example. You see people say PMID colon something, right? That's the accession number within PubMed for a paper, right? So it's basically the repository, some acronym for the repository, and then some identifier within that repository. A lot of repositories still use this method. And there are many good reasons for that as well, especially if one has, hundreds of thousands of data records. You may not want DOIs for all that. And I'll have to excuse myself. Been getting over a cold, so I'll try to not cough as much, but it might happen every once in a while. And so a number of people, a number of groups came together in Europe and the US, so as part of DataCite, which is a project looking to how does one cite data, and identifiers.org, which is a European project that deals with these database accession numbers, and the California Digital Library. So the California Digital Library is one of the main players in data citation in the US, working with DataCite. And so they've come together and built a global resolving service for these database accession numbers. So just like you can go to, I always forget what it is it dx.doi.org, where you can put in your DOI and then basically it sends you to the paper. If you go to identifiers.org or N2T, which is the California Digital Libraries Resolver, you put in a database accession number that is part of the system, they'll take you then right to that database data set. So again, this is starting to be plumbed, and so in the next couple years, you'll start seeing sort of a robust infrastructure for your data, just as you have for your papers. And this is all sort of then wrapped into this concept of FAIR. So if you've ever read an NIH sort of bulletin about data and what you have to do for sharing in the last year, you've probably come across those 4 letters. So basically the concept is a very straightforward one. For data to become open and used, well, it has to be findable, right? You have to be able to access it. If you want to be able to use it with other data sets, it has to be interoperable. And you also want it to be reusable, okay? And so I'll get into some of these more specific points as we go along. But again, this is a set of principles that doesn't specify exactly what one has to do, but it sort of gives you a target of what is needed to make this data open in a manner that other researchers can make use of it. And there's some common there's some simple things, as Dave was saying, that one can do, right? So the primary thing with FAIR data, and that's sort of, I think, what I'll be talking about a little bit when I get onto bids and some other things, is that FAIR data starts with good laboratory management, right? If you start from the get-go, knowing how you want to handle your data, having techniques and tools to work with that data so that not only yourself, but anyone in your lab, and even when you go on, if you're a graduate student and you go get a postdoc somewhere else and your data is sitting on a server somewhere, that you've left it in a way that someone else coming in can look at it, can use it, and work with it. And again, it might seem very daunting at first, but there are some very simple techniques, that one can start using to make that a lot easier. In earlier, many years ago, I set up a data repository for fMRI data, and at that time, to make it easy for people to submit data, we just told them to send us their data as is, de-identified as is. And man, that was what one saw coming over the fence was interesting in terms of how things were organized, and the little shortcuts people were taking, and the long conversations we had to have with people just to figure out what was going on in what would, seem to be, a simple construct, right? You take a subject, they go through a number of scanning sessions, you capture a number of types of, imaging modalities. Seems pretty logical, but the number of variants one can come up with as how to handle that, is interesting. In terms of managing sort of the requirements for findability and accessibility, most people suggest using community repositories, so either ones at NIH or there's Open Neuro, NITRIC, a number of other resources where one can actually go and place their data, and then it's also places where one can find data, to use. Journals, if you publish in a journal, you'll see that, a lot of journals now have lists of recommended repositories. Nitric and ReproNim and other places, also will point you at places. And there are also now data journals that are coming out, so journals specifically focused on publishing data. So instead of publishing a full article about the research and the analysis, you publish a full article about the methods and how the data was collected. Right? And so this is a little different than your regular, a research paper where, they try to remove as much of the methods section as possible because of, page limitations and whatever else. Here you get to actually describe, your methods and, how the data was collected. So another area where we have information on FAIR and this course is at, the URL reproducibleimaging.org, and that is some of the training. And so what I'm going to do real quick, let's see if I can, Yeah, no, that's, hold on, let me see if I can get to my browser here. So that looks okay. That looks good. So this has information on ReproNim, but then also has the various training modules also, where we have some other data about, or some other information about the training. And the times on this are not meant to be real times in a lot of the modules. But what you'll see is that there are a number of different sections. And so I'm not going to go over many of these sections, or actually most of them. So for example, the section on ethics, this is a big issue. And there are also a lot of new laws that are coming into place. So the GDPR in Europe, just became effective May 25th. That has a lot of impact in terms of how one has to handle subject data, especially if you're working with European colleagues. So the ethics section here actually links to, I think it's an edX course. So, all this content isn't ours. We've also tried to aggregate content and point people to various courses. So again, this is a very good ethics course. I think it was University of Michigan that put it together, you can go through edX and look at that, for example. Data publication, laboratory data store. Again, we point to a number of different presentations and areas that give you some information on how you might work through some of that. Semantic data representations, I'll talk about in the end of this talk a bit. But again, if you're more interested in RDF and Sparkle and how does one do queries and graph-based representations, you can look in there. And there, again, it points to a number of different sites that provide information. And so, the beginning part here, really we've been talking about FAIR. I've talked about, the identifier systems. This talks a bit more about identifier systems. Talks a little bit about, open and linked data technologies, which I'll get to in the end of the talk. And when we talk about the FAIR principles, there are actually a number of sort of directed aspects of what it means to be fair. So for findable, really it is this persistent identifier, right? That you have a persistent identifier and data are described with rich metadata. So that, it is actually discoverable. One thing that, is being worked on as well is that most people, if you want to find something, where do you go? Everyone goes to Google, I bet, or their other favorite, Bing, or, whatever they, usually people don't go to, a directed search site. So Google in the last year has started an initiative where they're trying to build in data as a first-class object into their search system. So if you've ever gone searching for movies or anything on Google and you see that little information box on the right-hand side, that is driven by what's called schema.org markup. So schema.org.markup is small bits of metadata that people put on their web pages that define certain items with various metadata attributes. And over the last year or so, Google has been working with researchers to do that in the data context. Because the issue is there are hundreds of data repositories out there. And so if these data repositories were able to mark up their information with schema.org markup, Google would have a nice way then to sort of aggregate that information, since that's where everyone goes anyway. That's sort of a first pass, to get people to this data and make it findable. The accessibility part, again, is mainly about, protocols, to allow access to that data, the appropriate authentication authorization. And the other important part is that metadata is available even when the data disappears. So this is, in the library sciences, this is the concept of tombstoning. So for example, if a journal goes away, or you no longer have sort of the digital artifact, so if you have a digital object identifier for a paper, you will always be able to get the metadata for that paper, right? You may not be able to get the actual paper behind it, right? So if the journal went away, I mean, the library community has other ways of dealing with this, so they have Portico and a bunch of other ways to back up this information. But in any case, for data, the amount of data that's being generated, there is a question, we can't really store it in perpetuity, every piece of data that we collect. So then, what data is important, what data gets sort of kept online. But if people are working with some of this data, or have in the past, there still needs to be some signpost somewhere out there in this digital space that says that this data set did exist, right? Because people might have publications that link off that, have derived data, that might still exist. And so that's a key piece of the ecosystem. The interoperability part really talks about that one is using sort of formal and sort of accepted languages for representation of the metadata, and that any of the vocabulary, so when you're using metadata, you're describing information, right? So the metadata that you use about an object, right, is also fair, right? So that when you describe, a data set, that you're using maybe an ROI, for thalamus or for motor cortex, whatever it might be, that if you say that, right, that there is some definition for thalamus somewhere, right, that you have used that others can reference, right? Otherwise, I could say cerebellum. What am I talking about? I may be talking about the rock band, because there is a rock band called Cerebellum, right? So, it is, things can be ambiguous even if you think they're not. And then the reusability part, talks about data licensing, which is very important. And again, this gets into the legal aspects as well. There are different legal aspects in various European countries versus US countries, and what the licenses entail. And that also data has appropriate provenance, and that the metadata sort of meets sort of community standards, right? So if we're talking about neuroimaging data, there's certain things that, we need to incorporate in the metadata to properly specify a neuroimaging experiment. And again, these are sort of high-level concepts, but are things that should guide us in terms of how we handle our data. Again, all this is online, so you can look at it later. Again, lots of links in all these sections for all our talks are there. So let me start this back up. Okay, so we've done that. Okay, so that was the first section, which was mainly my introduction. Anyone have any questions or comments about first section? Okay, go on to the next. So interoperable data and BIDs. How many are familiar with BIDs data sets? Okay, so about half, I think. And so the motivation behind BIDs, as I mentioned, imaging experiments are complicated, can be organized in many different ways. You have many files and file types, per subject. And, currently, if you're in a lab that doesn't have a standardized structure, everyone in that lab may do things slightly differently, right? So how they sort of feel comfortable. And that makes it difficult sharing data within projects, within a lab, across members of a lab, and across large-scale projects as well. And so what BIDS does, it's a standardized organizational structure and format that makes it sort of more amenable to sort of share that data and put it in a context where someone else can come in and say, yes, I understand what this is. Over time, more and more software tools are available that are using this structure. And there are also now repositories such as OpenEuro and NDA, for example. Someone's written a converter from BIDS to the NDA format. I haven't checked that lately, so I don't know how up to date it is. But I mean, people are, starting to develop tools and use BIDS as a way to sort of manage this this interoperability issue of data sets themselves. There are a number of open source efforts. One is a validation tool. So if you we'll try this, in a little bit to check data integrity. Now, the focus was originally on sort of the raw data. How does one aggregate the raw data? So what you'll see is that the specifications are growing. So if you go to the BIDS website, I'll have the next slide gives some information on different resources. And now, there's ways to sort of derive data. Now they're also looking at extensions for EEG and other types of data. So the specification is growing, and there's a robust community around many of these efforts. And so, if there's something that you would like to see added to BIDS, it's not something that you have to wait. You can actually talk to Chris or, get involved with a number of the groups and, work on extending BIDS to support something that may not be supported right now. So again, I think the other, concept that we want to get across is that, a lot of us and a lot of the tools that we're talking about and a lot of the groups we're talking about, are very open to getting more people involved, to expand the tools, to make them better. So that's, what we're here for as well. And so, in the slides, there's a number of links that can help you get started with BIDS. We're going to be doing something very simple here, so we'll start that in a little bit. I wanted to point you at OpenEuro. So OpenEuro is a repository of BIDS data sets. And so when you go in and look at these, all this information that the user interface is derived specifically from the BIDS data itself. You can actually see over on the side here, this is sort of the directory structure you'll see in a sort of a standard BIDS data set, where you have some of the informational files at the top level, and then you have the subject directories, that contain then the information for the various subjects. And in the BIDS spec, there is a whole sort of listing of, how that directory structure gets created. One of the core files is this dataset description.json. And this has basic information about the data set. And when one looks at the specification, this is the BIDS specification for the directory structure. So it gives you, the directory hierarchy where, all subjects have sub- some participant label, where that participant label, can be yours. And then, there's also, directories for stimuli, for source data. And if you look at the single session example, you have sub-control01. So control01 is your, subject, identifier for that. And so this sub-control01 also becomes then the naming convention for the anatomical files and associated files underneath that. So again, it's very straightforward. It's sort of a standardized way, to represent the data. If you were to lay out your data in such a way, I could go in and could start making sense because, again, I'm not getting into many of the details as, where the stimuli files, get placed and some of the other JSON files that describe, how stimuli, that, again, I only have an hour and a half to go over a lot of things, so I'm just going to stick, to some basics to begin with. But when you look at the specification, it talks about how all these other types of files and metadata get brought in so that you have then sort of a robust structure for that data. The data set description.json has some simple information that's required, the name of the data set, the BIDS version, and then a number of recommended and optional things. And so basically this is, the primary marker. So if you were to share your data, yep.
So one question.
Yeah.
How do we get those slides? Where are those slides?
Oh, that was, okay, in the very beginning, it's at the GitHub on here, I can go back to the,
Just making sure everyone's
yes. So if you didn't take, so it's github.com/repronim/OHBM 2018-training. And then we're currently in section 1. So if you go to section 1, there should be a PDF in there that everyone can download. And those are my slides, and I can't speak for everyone else, but there's a section 2.3 and a section 4, I believe, already as well. So everyone have questions about where that material is? Everyone good? Okay. Go back to where I was. Okay, and so this is a very simple bid specification of the main project information. Again, this is in JSON. How many people are familiar with JSON? Okay, so again, about half the room. Don't be intimidated by JSON. It's basically a very simple attribute value way to describe data similar to XML. And basically, you start, documents and objects with a curly bracket, and then you'll see the name colon. So that basically says I have an entity called name. Colon is basically equals, set this to, and then what's to the right of that, the mother of all experiments, is my name, right? And then comma, if you have another sort of entity value pair that you want to place. If not, if it's the last one, no comma, and then a closing curly bracket. So again, it's a very simple data format, and a lot of the tools that one sees uses JSON to pass data around. So there are some tools that one can get to work with JSON. So if you code and things like that, there's Atom, which also works with, Markdown and a bunch of other things. And then they also have, like on my Mac, I also have a nice little, JSON viewer tool that shows it to you in a tree if you want to. So, many different tools for JSON. But if you have any questions about that, let me know a bit later. Yeah.
Can I ask how many people are actually using the BIDS format for their data set? We show that.
Yeah, it's about.
So it's only.
Yeah.
Not that many of you.
Mm-hmm.
So I think it's worth having like a high level description of how these BIDS data sets are formed, right?
Yep. Yep.
And you're going to see that more in the that course.
Yeah, and so as I said, the main thing that we're going to deal today with is the directory structure, which, in the slides we, that was right here, right? So that you have a standard way to name the subjects. All we're dealing today with anatomical scans, so you'll have something very similar. Oh, okay. Okay. You'll have something very similar to this, sort of in your directory structure, and I think let me see. We did the the JSON. And so we're now at the first exercise, which is the basic bids. Okay, so if you're in your VirtualBox, in your home directory, yeah.
A couple of people came a bit late at the course. Can you
Yep.
just have a quick rephrase of the how we operate?
Yes.
Making sure that you have the VirtualBox and the virtual machine that you can launch. So if you don't, put a little sticker with the big sticker on your computer. Right? If everything is fine, you can put the yellow sticker.
Yeah, make sure the yellow sticker points up so that people from behind can see it as well.
No red stickers, so I think everyone's good. If I'm wrong, tell me.
Or does anyone have a no sticker? That's the other question. So that's the, yeah. Nope. And as we mentioned earlier, there are a number of people on that side of the room that can help if we have any red stickers or, if people are getting stuck. So again, this section, keeping it simple, but the data set that one creates here, we are going to use to do some Sparkle queries later on. Those of you who don't know what Sparkle is, you'll be introduced. Again, this is sort of more of an introduction, but basically to keep everyone sort of in the same area so we know what's happening, I started out instructions by basically in your home directory, basically the one that the VirtualBox drops you into. You can make their section 1, you could CD into section 1, and then you can copy some anatomical data into that folder. So the VirtualBox already has some data on it so that it makes, yep, oh, open terminal window, sorry. Yes. So in your VirtualBox, if you have the terminal window open, and again, these commands are in the PDF file too, so you can have that open right sort of next to you.
Copy and paste from the PDF into your VirtualBox.
Yeah, you have to type. In some place, on my Mac, I have trouble copying and pasting between the Mac and the VirtualBox. So, so this is sort of the first exercise. Again, we have a little bit of time to do this. To copy the data, all you can do is you can copy from this directory where we've downloaded. This is a sub-0 question mark. So what the question mark will do, we'll grab any number or any letter, and so you'll basically end up with 9 anatomical scans in your section 1 directory. Okay, and then what we're going to do is going to create a folder called Make Your Repro Bids, and that is going to be your bids directory where you're going to structure the data. And create your sort of your folder hierarchy.
Don't mind us walking around. We're just trying to make sure that we're coming here, looking over your phone, reading your email.
So let's, and yep.
PDF of the slides is section 1. Sorry. ReproNim OHBM training section 1. So how much time do we need people to
Moving the data is like 5-10 minutes, so we can see.
Let's give people 5 minutes. Let's do the exercise. Go to the data.
If you're having any trouble or sort of are stuck, just do the red sticker. We can help you. The PDF was in the GitHub, so go to github.com/OHBM training. Okay, so the last thing that we want to do is then move those into a structured directory, sort of into a formal directory structure within the ReproBids folder. So what I can, fortunately, I can't have two screens open for the data and the specification. So. Again, this should all work because I tested last night on the latest version.
Caught up with these instructions so far? Succeeded so far?
Okay. And how is it with putting them in directory structure? People still doing that, or that's sort of the open part of the assignment? Is one has to actually move them into the subdirectories. So what you should have is within the ReproBids folder, there should now be 9 subfolders with the subject identifiers on them, and then there should be an ANAT folder within each of those directories with the anatomy file in that folder. Okay, so again, we're trying to move this data so people who are oops, let me. Yep, yeah, no, that's what I was going to do. Huh? Let's see if I can. And does anyone know how to make VirtualBox larger? The font within the VirtualBox? Control Shift plus? Command Shift or Control Shift? Oh, there we go. Okay, there we go. Is that better? Okay, so once you've originally done and copied the data over, this is what you'll see. And so what you actually want to do then is, you need to actually make your directories so you can rename your subjects or leave them like this. So you would make your sub 01, right? And then you'd move sub -01, and you can hit the tab button. Whoops. Sub 01 underscore tab, right? That will complete the file name. So in the command line, if you tab, it will complete, and then you can move that to sub 01, right? And then you can do that for the rest of the files, and you'll end up then with the directory structure. And then if you go into sub 01, yep.
So part of the bid standard is that your subjects directories, where you're going to put your data files, they all start with sub dash.
Yep.
And then there's this unique identifier. In this case, we're doing 0102
Yep.
0 whatever. But those could be anything. But it's
Yep.
sub dash is the requirement.
Yeah, and that was in the specification what we pointed at before. And then within this folder, you can make an ANAT-dir. So there are certain directory naming conventions for anatomy files. And move sub 01 into ANAT, And so now, if I go back up, you know, and I do ls of sub 1, you know, that has its inat directory, and then the inat directory has, you know, the weight. And again, if you don't want to do all 9, don't have to do all 9. You can delete a number of subjects, but we do need a few subjects in your starting bids folder. And I know it's painful, but the problem is, and I've encountered this, is that if you start using automated tools from the scratch, you don't know and you don't remember what actually goes on. Okay, so you know, it's always good to do something manually once or twice. It ingrains it in your mind. I was actually surprised. My daughter's teacher in history this year forced them to write over and over notes and notebooks, because that is something, again, typing things on the command line like writing in a book helps you remember. Dave?
So one more point about the file names. On these file names, you'll see that it has this string of characters T1W. You know, that's sort of like a key phrase for bids, where they restrict that. So your images that are T1 weighted would have that T1W. There's other strings of characters, DWI in the spec, things like that, T2, and so forth. That string of characters you have to use exactly like it is to be a valid bids data set. So you need to have the sub in there, and you need to have this T1W part, or EPI or DWI or whatever the data is. So just something to remember. So in bids, you're mixing up the sort of organizational structure with some stuff in the file names that helps it determine what the images are.
So another point is you see the file type of these files are .nii.gz, so those are compressed 50, the NII is 50, .gz says they're compressed 50, is correct me if I'm wrong, can be either compressed or not, so it could be just NII, or it could be an NII.gz. Most software feels okay with either format. Zip is nice because of the less space, but on Windows, that's what they do, it just wants to have the GZ option. These are all zip files, they're fine the way they are.
Yeah. So don't try to put DICOMs in your inat directory or your bid validator. We'll say right now it has to be nifty.
Is that an appropriate place for the icon if you had it?
Not that I know of, but bids has a file at the root level that you can add called .bidsignore, and you could add all those files to .bidsignore, and then the validator will run, but you can still store files there, like .com. And there are automated tools for creating all this data
Yes,
structure
yes.
that we talk about later.
Yeah, and you'll, Yark and others will talk about ReproIn and a number of other ways to automatically do these conversions. But again,
You do it manually first.
exactly. And so I just kept 4 of them, and so that's what my directory structure looks like, you know, within Repro Bids. How's everyone doing? Is everyone sort of moving right along? So what I'll do is, I think some people have already created their directory structures, I think, and are sort of done, and others might still be working a little bit. The next part is still we're going to talk a little bit about the metadata. So let's see, 39 minutes. Who still needs help in creating their directory structure? Everyone? I can move on and. Okay. Okay, so Yep. Yes, yes.
Unix commands, actually done the whole course in proper order. There would have been, a little bit of basic education in Unix and Linux commands. So we kind of jump into this with that assumption, with that. So we'll see everybody have it.
Okay, so I know that some people are still working and are being helped. I'm going to start sort of on the next section a little bit, but we're going to come back to sort of the bids exercise in 2 slides real quick so we can keep on working on the bids. But the next section, we're going to talk a little bit more about metadata. And so here, Dave showed this slide before. We have a neuroimaging workflow, and at every part of this process, there is different types of metadata that is collected. Okay, everything from the acquisition details, the raw data, information about the raw data, which we're talking about today. How does one represent analysis and workflow, and the derived data? And so within the bid structure itself, there is the other file that we're going to be talking about is the participants.tsv file. So the participants.tsv file basically is a very simple, this is an example of one. So TSV is a tab separated value file, and basically each line, the first line is going to be a header. So participant ID, age, and sex, are sort of the most common and sort of required. And then other variables that you might want to add about your participants get added to that. And then each line is a separate participant. So again, this subcontrol your case, it's going to be sub-01. Okay, you use that same ID, make up an age, make up a sex, any other, you want to add another variable, you can add another variable. And so basically we need to create this file. It's called participants all_.tsv in that top level folder, and we need to fill it out with that information along with that data set description file we talked about earlier, right? So there are these two files, the data set description.json and the participants.tsv file. Okay, we create those, and then you will have a very minimal valid bids data set. In the repro_bids folder, right? So again, we're going into the repro bids folder. We're creating this participants.tsv file and also the dataset description.json file. And then we have a Firefox browser within within our VirtualBox, and then I'll show you how you can actually use one of the online validators. The dataset description.json file. So that's why it's handy to have that PDF, because that describes the. Yes, yeah. So when you're in your top level directory in the repro bids, you would need to edit a file.
You recommend VI or Emacs?
I use Emacs, but yeah, so.
VI or Emacs, what do we recommend for this?
Text edit.
Yes. Oh, you could do text edit too.
There's a GUI in Ubuntu.
Yeah. Yeah, is that this guy? I usually gedit. So gedit data set description description.json. Okay.
Unless you want to do Emacs or VI.
And so again, can I make this? Now I have to make this window bigger? I don't know if I can make this window bigger. It doesn't want to. Control plus on this? No. No, not the other window it does. So basically I did gedit dataset description.json. It's going to be hard to see, but I opened with an open curly bracket. I could tab in, to make it pretty JSON, and then its name in quotes, colon, and then you could type, my great study, and then end bracket, and then the other, there were two required things. One was the name and one was the bids version, right? So if one goes back, if one's in their notes and looks at the bid specification for dataset description.json, the other one is bids version, capital bids, capital V. So let's go back to my VirtualBox. So this is basically the line where it says bids version 1.01. So I'll go, I can add that. Bids version, oops. And make sure after the first line you have a comma so that it knows that there's supposed to be multiple lines. And then I can save this from gedit, and then more data set description. And you'll see that now, I have the two required elements. And then I can do a gedit participants.tsv. Okay, I'll get this. And so again, you have in the documentation what this is supposed to have. So I need to be able to spell it correctly. Participant ID, tab, age, tab, sex. Okay, and then I have sub 01, tab 20, tab male, sub 02, 24, female, sub 03, 18, female, and sub 04, 28, male. Okay, so very simple file that I created. Okay, and again, they might not line up because just because the tabbing is participant ID is a long field name. So Control L.
Can you show that again?
Why do you?
Back up there.
There you go. So you figured you'd come to OHBM and you could see a lot of things, we wouldn't put you to work.
So this means we only use the first and fourth
Because I've been
do tab, age, tab, sex. You're creating this file yourself.
You want to do 9, you can do 9, you can do 4.
There you go. Yeah.
But this validated in real world.
There's no data set extraction?
Or the other way around. So you
Yeah,
say,
so and we'll try this. We'll do the validator. I should actually see if this is valid.
So, how people are doing?
Catching up.
Please put your red or pink little sticker if you're in trouble. Put your yellow sticker up if you're doing well.
I think everybody's still working on
Still working.
catching up.
Perfect. Let's take 5 minutes to sort of like create your first bits data set.
This time I'm You're not making this part of my part.
I seem to have lost my.
Okay, you're ready. With the 4 lines there.
Okay, so does anyone know how to get me out of the? Oh, there we go. Okay. Browse. Section 1. Repro bids. Upload.
Wait, do you want them to go to the website, Jeff, to validate?
Data set descriptor. Did I mistype that? Hold on.
Okay, so wait, Jeff, can you show the web
Oh.
page that they should go to?
Yeah. Hold on. I was just. Yeah. So in the files, there's a. The URL is incf.github.io/bids-validator. Again, that's in the resources, the bids resources that I had. And so let's see if I did everything correct. Let's see, what does it say I still am missing? Yep, yeah, no, I probably. Here's the name. Oops, let me go up. Oh. Where did my G-edit go? Aha. So I made the mistake of lowercase name. Okay. Okay. So see, even when I'm typing fast, everyone makes mistakes.
Can you show the
So
data set description and participant file just on the terminal windows?
yes.
Type it. Okay, so you type gedit.
Yeah, and description with a C, I had a typo before, and so didn't know what the file type was. So. And sorry for making a mistake. The N needs to be capital in name. So needs to be capital N.
You're going to type
Great that you're making some mistakes.
but
Because that's
capital N for name.
It's on the bottom now.
All right.
Capital
Don't
N.
touch. Yeah, it's down here.
Yeah.
So capital name, quotes.
And that's a real life thing. I mean, you will make some mistake in the creation of the bits data set. There's the validator is going to tell you that's not a valid data set, and you have to correct this and this and this. And that's so that's how you proceed.
Oops. Okay, there we go. No, I was trying to get this as a window. So, okay.
Is anyone lost? Yeah, one person. You have two people to take care. Okay.
Gedit is a graphical editor, so it brings up that list.
So basically, I need only supports Firefox.
Firefox and Chrome, but there's in the VirtualBox there's Firefox, so you should be able to launch Firefox in your VirtualBox. And it's Firefox and Chrome.
So your virtual machines
Have Firefox.
your virtual machines are Linux virtual machines. They are Ubuntu virtual machines. So inside your Windows or your Mac, there is this Linux virtual machine. And inside this Linux virtual machine, you have Firefox as a web browser.
So has anyone validated their bids data set yet? Woohoo! Okay. Successfully? Okay. Well, if you don't get any errors back, then it's a success. No. It's relative.
Is it singular? Sorry, the name of the participant file, is that going to be singular?
Participants.
It is participants, so he's right. So we're having a validation error over here.
Well, I can open it in Janet because
So When you're doing your validation, you have to click on the vagrant on top to select, and then you can go down into section 1. So when you're doing the browse, right here, you'll see that the top left is vagrant, and that will take you to your home directory, and then you can go into section 1 and select your repro bids folder.
Well, no, the problem was that the VS Code is replacing they tabs into spaces.
Yeah. I might.
So one thing that we did, just experience was if you've put any other files in this directory, the bids validator will complain. We're not going to talk about the bids ignore, which you can put in. So the easiest thing to do is just move them out if you've put some other scripts or whatever in that directory, because bids is going to complain about that.
So we're going to give still a few minutes, and in a few minutes we'll declare a victory and coffee break. But before the coffee break, we would like to have at least 90% of the people having done the exercise. So we need the yellow and the pink stickers to show us, how far we are from the break.
In the TSV file, they have to be tabs between the various elements, not 4 spaces or what might look like a tab. So they have to be tabs.
So the question, I've got a question, which is, do we have to rename the files to make sure that it is a bits data set? And the answer is yes. The bits for specification is both the hierarchy of the directories, okay, so subject directory, session, and so on, and the name and the file names. So it's both those things, plus the information that you have in the TSV file in the JSON file. So those are mandated by the bit specification. Yes, so the bit validator, that's what you is looking at your directory, is looking at the name of your files, and is checking that the directories and the name of the files are conform to the bits specification. So you need to rename all those things, all those files, before you launch the validator. The validator will, if you don't, the validator will say you that's not a bits data set, and this is what you have to mend and to correct. Yeah.
So JB, I mean, another 20 minutes or so, or?
No, I think if we can finish the exercise, get a coffee break, and then how much do you have to still do? Because
Well, I mean, I can show the next part just really quickly, so that's why I said I can do it in like 15, but they don't have to do any hands-on stuff.
because I
They can
think
do it
we,
later. Okay. Yeah, I should be done at 10. And then Dave ran a little late, so I mean, but if I get like 15. I was just going to show the Pi 9EM. And well, no, I can show it in slides.
Okay.
Not for them, but they can come back and do the exercises later. So I just so I show them what's there. So
Can you confirm, Jeff, that all of the Jeff, can you confirm that when we're doing this validation, all of that data stays local to your computer?
yes,
Even though that says upload,
yeah.
nothing is being uploaded. So this is all safe for your own local data. There's no sharing concerns. The validation happens locally.
the validation is inside the browser. It's not. Nothing is transferred through the network. Everything is local. All right. So before the coffee break, how many people are in trouble, and how many people can you? I think we are mostly good, right?
Yes, and again, I mean,
Okay.
the state we're at now, what I'll show after the coffee break, you don't have to do hands-on right now. You can do it later. You can try some of this later. But I think we're breaking for coffee now, or do you want to? Was it now or
How about we?
just do 15 minutes and then break for coffee?
Yeah, maybe if we could. So who votes for a coffee break now, and who votes for having like 5-10 minutes of
Wrap up.
wrap up? Coffee now. One. Yeah?
Okay.
Okay. So coffee now, and be back in 10 minutes. Be back in 10 minutes because we are running a bit late in the schedule. So please, you can leave your computers in the room. We'll be staying here and watch over your computers. resume at 10:15. So just to make sure everyone is on board, we're resuming formally at 10:15. Take your coffee break now, because you will need coffee.
So just to let people know, they've removed the coffee and tea, but there still is water in the back of the room. So. Yeah. Okay, as people start trickling back in, there are a number of other sections in here. What I'll do is I'll just give a brief overview sort of what the concepts are. People can go back in later and try out some of the commands. But basically, one of the areas that we did talk about with fair data is metadata. And so I think everyone here has probably heard about, common data elements. And so a common data element is where you describe, for example, what participant age is, right? That it's the age, with a specific unit, potentially years, of a participant at a certain time. And so a lot of data repositories require you to use these common data elements. In this slide deck, we'll show you, it shows you one place where you can go look at some of these and explore some of these. One of the things I do want to tell you a little bit is that there's, also this idea of ontologies and terminologies. So if I talk about age as a concept, right, that's sort of a nebulous concept, right? So age of what, right? And so what the common data elements do is they refine that common term to say it's an age that represents something. So it's the representation of the subject's age at the time of the scan, for example. When one looks at a common data element, one can see that, for example, participant age is a measure of age, right? And so one can relate all these common data elements back to the actual terminology that defines what age is. And again, this might seem, well, why such a simple statement? The issue is that you have hundreds of thousands of common data elements, and you need some way to actually map these things together. So when one looks at the world as sort of a graph of interconnected objects, what we're starting to create is this sense of participant age, scan age at time of scan, A, for somebody, if they just have, some weird shorthand, all represent the age of the subject, when the acquisition session occurred. And so within ReproNim, what we're also looking at is how to do those specifications as well. So again, part of this slide deck talks about that. We do have a tool, so interlex.org. You can go there. You can search over ontology. You can search over common data elements. It's a simple search, and then you get returned a list of these. So you can explore that a little bit. If you do some programmatic work, this is also available through services. And then behind that, we turn this into a set of ontologies so that there's a more formal ontology. So if you haven't heard about ontology, it's a formal representation of these terms and how they relate to one another so that you can actually start reasoning. So if you want to say that, I'm looking for all types of, neuroimaging data, right? So neuroimaging consists of a bunch of different modalities. So a system that is meant to use that information needs to be able to tie those things together and say, oh, I know what neuroimaging is, right? It consists of fMRI, PET, all these other types of options. And so that's what the ontologies do. This is also available in GitHub. And again, I'm going through this very quickly, just sort of you have all this information on your own. Within ReproNim, for example, Satra's group is developing Brainverse. So the goal here is, as you're actually setting up your forms to collect information from subjects, you're doing a lot of this mapping to terminologies and CDEs when you actually set up the forms. So all of this alignment that one would have to do later on has already been connected. And then the last section talks about the neuroimaging data model. So we talked about BIDS, and so what NIDM lays on top of BIDS is additional information about the experiment, about the results. And so again, when we talk about mapping data, so you want to map information about the subjects, what they did in an experiment, how they relate to their files, that in itself is also a graph. Right? And so what NIDM does is represent these experiments as graphs, so you can do some things and tools can be built on top of that to search across the data within your own local file system, for example. One of the areas is an IDM experiment. And what this section goes over is a very simple overview of an IDM experiment and the tool PyNIDM, so some Python tools that work on this NIDM data. And again, the PyNIDM is what brings together the terminologies and the data and puts it together. And so behind the scenes within PyNIDM, what you have is a bunch of files that define how things map. So if you see here where it says NIDM subject ID, right? So a subject ID here is related to this common data element from the NDA archive, the source subject ID, right? So there's a common data element called source subject ID, and all the IDs within NIDM for participants get mapped to that concept. So no matter what data set you have in an IDM representation, and again, if you're working this off bids, that's an easy conversion. Everything that has a subject ID is represented as that common data element. So if you have different data sets from your lab across labs, you can actually start doing queries across these data sets. And that's the whole concept of linked data, semantic web type tutorial. So again, this sort of walks through some of this, and I'm not going to cover this here. There's the graph model for NIDM. We have additional NIDM resources. So about the overview, there's a primer on NIDM. And there are also tools being built around NIDM. So many of us were at the hackathon the last couple days. There's tools to generate NIDM results. So what we've been talking about is how does one set up information about the experiment, about the subjects, the tasks, the files that were collected. On the other end, you can actually generate these NIDM representations of results. So you map these to a common structure, and what's nice about that is that there are tools now from FSL and SPM to export your results as NIDM. You can share them with someone else, and they now have viewers within SPM and FSL. So if someone that you know of uses FSL for their results and you don't know how to use FSL, but you use SPM, if they export as an IDM, you can actually import into SPM. You can take those results and bring them into the NIDM viewer within SPM, and you can now work with someone else's results and see what they have. So again, these sort of standardized structures for data allow this type of movement between systems. And then there was another exercise that I'll point you to that uses Conda to run some of the experiments, and we have what this generates at the end is what's called a turtle file, a .ttl file. You'll notice it's a little. It might seem a little daunting, but basically all it says is, I'm going to look here, is basically, you have, a certain object, it's basically this triple type representation where you say something is a something, right? And that's how you create a graph. You have one node is related to another node in some way. So you can say a subject, has, a session, and this session has an acquisition, and then this acquisition, has an anatomical scan. And so basically you're building this graph up, of what is contained in the data. Once you have that graph, you don't need to know that this is a graph, right? Because you can, through, let's go, through the, there's a bids to NIDM converter. I have to fix the slides. I think one of my slides disappeared. But there is a bids to NIDM conversion within PyNIDM that does an automatic conversion from a bids data set into NIDM. And again, a lot of these tools are open source and being developed and being worked on. So again, these are sort of community developed tools. And once you have that as an IDM represented document, you can actually run what's called a Sparkle query across that. And again, a lot of these tools are being developed so that a lot of this graph nature of the data is hidden from you. So you'll be able to execute queries through PyNIDM. That's not, I don't know, Dave, when that's sort of on the roadmap, but I think some of these simpler queries are one of the goals of PyNIDM at some point. So you don't actually have to issue direct Sparkle queries. But these are things that are in development. But just wanted to sort of highlight them here. But if you want to experiment with Sparkle, basically Sparkle query, you're trying to do a graph match, right? So you're defining, this statement down here basically says that, oh, I have a person, that has an associated acquisition, which has an assessment related to that, which is age, okay? And this person also has a subject ID, right? So it's going to look through its entire graph and say, okay, do I find graph structures that match that? And if so, I will return them, okay? And so basically, instead of, looking in columns and saying, okay, well, does this column have this value and does this column have this value, which I think, most people are more familiar with in terms of the standard way one queries a database, right? You say, I want to, I have a table and I want to find all the columns that have, an age of 20 or something like that. What this allows you to do is then do more complex queries across these graphs, because you can tie in information then, if this person, has, some other assessments or has some other data associated with it, you can just expand that sort of graph that you're trying to match. And so that's sort of what's behind in terms of the graph databases. So that's just sort of an overview of how that happens. There's a command there, once you have the NIDM turtle file, that allows you to, do those types of queries. So again, if you have any questions about, some of the more advanced topics, you can come and ask me. But I think that sort of wraps us up for the first session. And then Dave had a...
For the experiments that we're not going to do.
Yep.
Is there an answer? Is there an answer key somewhere?
Yeah, I will. Yeah. So Dave asked, for the questions we hadn't done, is there an answer key? I didn't put the answer slides in, but I can add them and I can re-upload that to the GitHub repo.
So clearly this part is a little bit more advanced. All the sort of the annotation of those terms that are in the TSV files are really important, but it's clearly like a more advanced topic. So please, there's a lot of information and documents on the web, on the ReproNim Training website that is on GitHub that you can have a look and I think we can maybe take one or two questions if there are some questions, and then we'll start with the next section and leave the space the podium for Jarek and Michael, I think, on the computational basics section. Any question for Jeff before we yeah?
So I'm really interested in the Sparkle add-on, so to speak. So in my understanding, Sparkle is used to by statisticians in order to provide the data as well as a means of saying, well, these are the queries that you can do on the data to extract statistics or things like that.
The Sparkle is the query language itself, so
Yeah.
people can create templated
That's
Sparkle queries across a data model.
Mm-hmm. So can you hook that up to stats packages?
Yes, so basically the example in here, you'll see at the very end of so it uses RDFlib. Let me go back to it's sort of hard to see, but on the bottom, there's the print statement. So basically, for each set of results, you get your printing in Python, how you want those results to appear. So if you need a TSV file, just change the print statement to, have the tab. Yeah, exactly. And so when you run it, so it's RDF-lib run through Python, so you can output whatever format you want.
There's libraries
Yeah.
Yeah, I'll just add to that very quickly. So that query can be returned in all kinds of formats. It could return a CSV file, which you can then import into R, SPSS, or other things. So there are many ways of returning the information that fits into stats packages or libraries.
And then the other thing that I would, the way I look at Sparkle is if you're used to databases and you're in like SQL query language, Sparkle is just a richer query language that you can use for graph operations and things. And it's pretty nice once you learn how to use it.
And there's a curve, there's a steep curve for that. Yeah.